Ta-da!
I'm Monaco,
I'm Milks.
and we're going to hit up homework number 3.
Three.
We're going to talk about Amadeo Avogadro and his mole theory.
Yeah. So this is the heart of it. He was the guy that figured out specifically that equal volumes of gas have equal, under same pressure and temperature, have equal numbers of particles.
That's odd to say how, okay, if this is this size at this temperature and this pressure, it's got the same number of atoms, which is the exact same size, the exact same temperature,
Right.
exact same pressure. When you think about it, it's really not that tough.
No, but it was revolutionary in the fact that the size of the atoms or molecules at the time could be drastically different.
Right. And also, this was like a long time ago.
A long time.
No computers.
No.
Dude did it with mathematics and ratios, and
A lot of trials.
he deserves a lot of credit for it.
And he got a lot of credit for it. As a matter of fact, he got Avogadro's number named after him in Avogadro's
Many years
law.
later.
Yes.
Yeah, he came up with the theory, this equals that under the same conditions.
Right.
And then many years later, they proved it and said, wow, this is really important. We can use it to count
Yeah.
atoms in chemical reactions.
Totally.
And so we should let this guy have some credit.
Yes.
And when they actually figured out what Avogadro's
Yeah.
number was,
He's from Italy, you guys.
Yes, he was.
And so now we use this a mole tool to count atoms because I cannot count atoms in the lab. Like, they're just way too small.
Only recently did we get the technology to actually see atoms under an electron microscope and forget counting them because there's way too many.
Right.
Way
So
too many.
we figured out a way now to turn this moles into grams. And that's basically what we're going to use it for.
Mhm.
Right?
Yeah, that's what we chemists use moles for. We have to count and show ratios of chemicals to compounds and reactions, but we can't actually count compounds and atoms. We have to weigh things on a scale.
Right.
Or use a different way to measure the number of atoms in there. So that's what we use mole theory
we
for.
not only can do it, we can do it very accurate.
Yes, very accurate.
So moles related to volumes. We need to know
Yes.
that 1 mole of any gas at STP, standard temperature and pressure, so under those normal conditions, 1 mole of gas is 22.4 liters, capital LB liters.
And this is another reason why we need STP.
Yes.
Because if
We need the conditions to be the same, otherwise,
Amadeo's law doesn't apply.
correct.
If the temperature and the pressure aren't equal, then the volume and the number of moles won't
Right.
be equal either, and it doesn't work.
Right, so 1 mole of carbon dioxide at STP would be 22.4 liters.
A mole of
Carbon dioxide.
any gas at STP,
How about hydrogen?
22.4 liters.
And okay, and that was
Oxygen would be 22.4 liters.
yes.
Ammonia would be 22.4 liters.
It would.
You see in the pattern here?
Yes.
If it's a mole and it's a gas, it's 22.4 liters.
And now the mass piece is where we get to have some fun.
Yes.
So, by rule, 1 mole of any element is equal to its atomic mass in grams.
Right.
So if I can take those AMUs and just put the grams at the end, we good.
Yeah, and I can put grams on the scale. I can't put AMUs on the scale.
No.
But I can put grams on
Yes,
the
you can.
scale because they will weigh.
Yes, and it just so happens then that carbon, 1 mole of carbon then is how many grams?
12.011 or something
Done.
like
Isn't
that.
that exactly the same number on the
So
periodic
you
table?
mean to tell me if I have to count a mole of atoms,
Yeah.
I can do it with a scale?
We can do it with a balance, actually, yeah, and mass them, without a doubt.
But that's not counting.
Well, but see, we're
It
going to
is.
make it a jump.
It is because you can count by using Avogadro's number in this theory. That's
Yes.
why we chemists
Yes.
created it.
It's why we use it.
But we didn't create it. We use it.
So lithium is
7 point something.
It's 6.94.
I always round.
Yeah.
So in this scenario, we're not actually rounding those masses.
for right now. We're not. We probably will when we get into actually calculating.
Okay.
But for homework right now, we're not.
That's fair.
You know.
Yeah, 14 grams, I think.
Yeah, it's like 14.
I'm so good.
14.01. Yeah, you've done this before.
14.0067 actually.
Oh my god.
It's not like there's a periodic table up there. I memorized them all, kids. Come on.
Yeah, I didn't. But
I didn't either.
Good. All right. So and then we can do numbers of
Particles.
which is something we're not going to ask you to do a ton, but we need to know that there are specifically Na equals
Avogadro's number.
which is 6.02 times 10 to the 23, which is enormous.
So many.
We're not even going to
Mad many.
contemplate that.
If I had a mole of pennies, I would have enough money to give everybody on the planet
A trillion?
$1 trillion.
$1 trillion.
If I had a mole of marshmallows, it would like cover the entire surface of the planet, oceans and everything.
The number
like,
is actually
miles
so
deep.
large that it's hard to comprehend. Like space is how it keeps going and going and going. Our brain can't comprehend that.
Right.
This number is so large, we really can't.
There are more atoms in 1 mole of carbon, which I can hold in my hand, than are stars in the observable universe. There are grains of sand on our planet. Okay, it's crazy. So don't think about it too much, except on the definitions.
Why is it so useful?
Yeah,
well,
'cause-
check it out. It makes it so we can count these atoms.
Mhm.
So now these chemical reactions happen in simple whole number ratios, right?
Yep.
And these ratios of numbers of moles of products and reactants, and then we can play games with these moles, and we have fun.
I want to point out in this picture, which is a really good one, Mr. Mills. Everybody knows we can measure pounds.
Yes.
Count a dozen oranges, weighs 5 pounds, 5 pounds per dozen. You can do math that way.
Yes.
You can say, well, I'm going
to go to the store and get
how
a
many
pound of
oranges
oranges.
are in 20 pounds? Well, you multiply by 4, and there we
Right.
go.
Right.
Atoms, AMUs, well,
I can't be measuring that, mister. It's too
no,
small.
way too small. But here we get grams, a measurable quantity of grams at that.
Yes. So 1 mole is so many grams, and that is the jump that we're going to teach you how to make by using your reference table and turn that AMU mass into grams per mole.
Yeah.
Okay. How many grams are in a mole? And that's it for video 3. You're doing
Page
good.
7.
Practice packet.
Mm-hmm.
All right.
Do those pages.
Yeah, let's do it.
I don't want to
Come
have
in,
to force
check,
you all to
get
do
your-
stuff
yeah,
if you
come
didn't
in
do your
and-
homework.
Come in and get your stamp and check your answers. And by all means, if you have questions, that's where we start to fix the issues that you have.
We can have it a discussion so we can focus on what you need and not everything.
We can talk with or without our hands.
See y'all later.
See you guys.